This video is about periodic trends, and this is something that is on the AP exam and is something that you really need to know. So, we're going to start with the periodic trend atomic radius, which is basically size, and it's called radius because if you put two atoms together and you measured the radius of the atom and then the radius of the other atom, that would basically be the size of the atom because it's half of two atoms. And that's how atomic radius is measured. Now, we're going to look at what happens as you go down a group and across a period in the periodic table. Now, as you go down a group, atomic radius is going to increase. That means they get bigger. And most kids don't have any trouble with this because that makes sense to them. And the reason they get bigger as you go down is you add an energy level. Every time you move down one in a group, you add an energy level. And of course, this means the electrons that are in the highest level are further and further away from the nucleus. And because the distance between those valence electrons and the nucleus is larger, there's going to be a weaker force pulling the electrons towards the nucleus, and that will make the atoms larger. Remember, the positive nucleus can pull the electrons in, but the further away those electrons are from that positive nucleus, the weaker that force is that pulls the electron cloud towards the nucleus, making those atoms larger. Weaker force, larger atom. All right, we are going to now look at as we go across a period. So as we go across a period, which is a row, this is the one that gives kids trouble. The atomic radius is smaller. Even though we're adding protons and electrons, they get smaller. And the reason for this is, and you can see that they get smaller as you go across a row. But the reason for this is that anything in the same row has the same number of energy levels. And even though they have the same energy levels, they have different numbers of protons. So as you go across in a row like this, you add protons, but you don't add energy levels. Well, the more protons you have in your nucleus, the harder that nucleus can pull electrons. So having 9 protons versus 3 protons, 9 protons can pull harder on the electrons because that's a positive 9 charge pulling on them versus a positive 3 charge pulling on the electrons, which are all about the same distance away. So a bigger charge in the nucleus can pull the electrons in more tightly. That makes a stronger force pulling on the electrons, and that will make the atom smaller. So because the protons increase as you go across a row, but the energy levels don't change, the protons can pull harder on the valence electrons and make the atom smaller. All right, this is what you're going to have to do for the test. You're going to have to write paragraph responses that compares two atoms, and you're going to have to justify your answer. The first thing you have to do is make a claim. Then you have to provide evidence for that claim and justify your answer. So give your reasoning. So first of all, you have to decide which is smaller, nitrogen or arsenic. So what you do is you go and look at where they are in the periodic table. You find them. Nitrogen's right here, and arsenic is in the same column, but it's below nitrogen. Well, remember that as you go down, we add energy levels. And they get larger because you're adding energy levels, you're making a bigger distance. So that means that nitrogen will be smaller than arsenic. So that is our claim. So we go over here and we write our claim first. So nitrogen is smaller, and I apologize for my handwriting, it's hard to write with this pen, than arsenic. Now, I have to provide evidence. All right, so nitrogen, you could tell how many energy levels it has. Has 2 energy levels, and energy I abbreviate, and they would know this on the College Board, so they'd be okay. Energy levels, NRG is energy, and arsenic has 4 energy levels. Just look at what row they're in. Or you could write out their configuration if you wanted to do that. All right, now, that means that nitrogen, so there is less distance between nitrogen's valence electrons because the number of energy levels affects the distance. Nitrogen's valence electrons and its nucleus this makes the force stronger. The force pulling on nitrogen's electrons, and sorry, I'm having trouble again with this pen, electrons stronger which makes the electron cloud. This is one thing you could say, the electron cloud smaller and the atom smaller. There you go. That is a justification. That is, you've got your claim. I've got my evidence of the energy levels and how that smaller number of energy levels gives you less distance, which makes the force stronger that pulls on nitrogen's electrons, which pulls the cloud in tighter and makes the atom smaller. So that's what you have to do. All right, let's do one more. All right, this time it says which is smaller, copper or chromium. Again, we have to look and see where they are in the periodic table. Where there's copper and there's chromium. So they're in the same row. So we got to think, if they're in the same row, what do we argue? Well, we have to argue that they have the same number of energy levels because they're in the same period, but chromium has fewer protons in its nucleus pulling the electrons. And so the force pulling on chromium's electrons is weaker than that of copper's, and that's going to pull the cloud in less tightly and make chromium larger. Oh, wait, we got to tell which one's smaller. So we got to do it the other way. So copper is the smaller atom. I forgot I was doing larger. So copper is going to be smaller because it has more protons. But you have to talk about both atoms or you will not get credit. So I want you to write these properly. So copper is smaller than chromium. Now the evidence. Both, could say, have 4 energy. Oops, I shouldn't say both has. Both have 4 energy levels, or you could just say the same energy levels. Both have 4 energy levels, but copper has 29 protons because that's its atomic number. And chromium, you got to look at chromium's atomic number, has, I think it's 24. In fact, I know it is, has 24 protons. So there's our evidence. Now, how does this evidence make copper smaller? Is what you have to do. So, more protons increases the force of attraction pulling on the electron cloud in copper, which makes copper smaller. And there you go. So it's not too hard. Now, if I'm going too fast, pause the video, rewind, whatever you need to do in order to understand this. We will work on it more in class, but I really need you to work on understanding this before you come on Thursday. All right, let's go on to the next thing. Next thing we're going to talk about in this video is ionic radius, which is similar to atomic radius, except it's talking about when they become an ion, when they've lost electrons or gained electrons. And the first thing we're going to talk about is cations or positive ions. Cations obviously have lost at least one electron, and that's how they got a positive charge. So we're going to look at a couple examples, and then we'll write a paragraph about one of them. All right, so we'll look at sodium first. Sodium's number 11, and as an atom, this is its configuration. It ends in 3s1, but we know that sodium is in group 1, so it's going to lose that electron in the highest level. So it gets a stable noble gas configuration like neon. And so as an ion, a cation, it's going to have that configuration. Well, this is like losing a whole energy level. They lost an energy level when they gave away that electron. Magnesium is kind of similar. It's number 12, so this is its configuration as an atom. But we know everything in group 2 is going to lose 2 electrons, and they're going to attain that same noble gas configuration like neon. And so they also lose an energy level. So cations are always smaller than the atoms they come from because they lose an energy level. And remember, if you have fewer energy levels, there's less distance between the nucleus and the valence electrons. And so that force pulling the electron cloud in towards the nucleus gets stronger, and that makes the cation smaller than the atom it came from. So cations are always smaller than the atoms they come from. All right, here's an example of a paragraph you could be asked to do. So which is larger, K or K plus? Justify. All right, so we have to decide, well, that's a cation. So one of the things that really helps kids is to just go ahead and write the configurations for both. That can be part of your evidence. So I'm going to write that up at the top. So K is 19. So its configuration is 1s2, and I'm sorry this is so messy, but it's hard to write, like I said, with this pen. 3s2, I'll try to write small enough that I can fit it all on one line. So there we go. Now K plus 1 still has 19 protons. It loses an electron. And so it's going to become like argon. So we can easily see when we write this that this has an extra energy level. So K plus, oh, I want to know what's larger. So K is going to be larger. K is larger than K plus. Now, what is the evidence? K has 4 energy levels, while K plus has only 3 energy levels. This means there's more distance between the nucleus and valence electrons. In K. This makes the force of attraction, or let's just say weakens the force of attraction, or you could call it the force pulling on the electrons. I'm going to call it force of attraction here. On the electron cloud of K, which makes it larger. Hopefully, if you practice enough of these, you'll get better. Just takes getting used to. So there we go. We've got some extra evidence to support this right up here. So that's a good idea to write the configurations of a cation and an anion, a cation and the atom it comes from. And now we're going to do the anion and the atom it comes from. So this is the last thing we're going to go over. Actually, hang on, that's the same thing. What happened? Oh, there we go. All right, so ionic radius now with anions. Anions are negative ions, and they're negative because they've gained electrons. So if we look at an example of this, we see that oxygen, it's got 8 protons and 8 electrons as an atom. So that would be its configuration, 1s2, 2s2, 2p4. Then, as an ion, it gains 2 and fills up this energy level. So it's now going to have a -2 charge, and it's going to be like neon. Well, we didn't add any energy levels. So that's not going to be and we didn't lose any energy levels there. So this is a little harder to understand. But let's look at what happens with chlorine when it becomes an ion. This would be chlorine's configuration as an atom. It has 17 electrons, but it ends up with 18 electrons as an ion because it gains 1 to get like argon. Remember, everything in group 17 gains 1. Now, anions are always going to be larger than the atoms they come from. So chloride is bigger than chlorine. Oxide is bigger than oxygen, or they're called ides when they're negative ions. Now, the reason for that is not that we're adding energy levels. It is that we are adding electrons to the same level. What happens when you put extra electrons in the same level, but we haven't added any protons because chlorine and chloride have the same number of protons, then those extra electrons being in that same space, they push against each other because they're all negative. And we say that they have more electron repulsions. They repel each other. And because they repel each other, they push the cloud out away from the nucleus, and they make the anion larger than the atom it came from. Now, you probably won't see a paragraph on this, but we will be using this later on. Well, we'll be using it in the next example where we justify a bunch of things by size. We put stuff in order of increasing size. All right, but we'll do one paragraph to demonstrate this. All right, so which is larger, arsenic or arsenide, the ion? Well, remember, the first thing you might want to do is to write electron configurations for both of them. Now, I might write a noble gas configuration just because this is a little bit longer and I'm trying to fit this in, because arsenic is number 33. So I'm going to do a noble gas configuration here. So we're going to start after argon's 18, and we'll do 4s2 because argon ends in 3p6, 4s2, 3d10, 4p3. Now, arsenide is a -3 charge. That means it's gained 3 electrons. It's going to be the same as arsenic, but it's going to have 3 extra electrons. So it'll be like krypton. All right, so there are those configurations. So which one's larger? Well, this one is going to be larger because it has extra electron repulsions. So we're going to put, you can't just say because it's an anion. Arsenide is larger than arsenic. All right, what's the evidence for that? Arsenide has 3, more. That doesn't really look like a 3. Hang on, let me fix that. Has 3 more electrons in the 4th energy level, but has the same number of protons. As AS. The extra electrons, extra. You know what? I'm going to change that. I'm going to write this increases. Make it a little shorter. This increases the electron repulsions in AS3, which makes, we'll just say which pushes out the electron cloud, making AS3, AS negative 3 larger. All right, that's it. Hopefully you can write these paragraphs. If you forget how to do it, you don't have to write them exactly like I do. In fact, I don't want you to necessarily copy me, but you need to have the claim, you need to have the proper evidence. You can word it a little differently, and then you need to talk about what happens to the force and how that makes the atom smaller or larger. So all of this comes from that Coulombic attractions, understanding those Coulombic attractions. All right, we have one more question to do. One of the questions I'm going to ask you to do is to arrange atoms and ions in order of increasing size. Now remember that the size depends more on the distance, which depends on the energy levels, than it does on the number of protons. So the first thing you need to do when you're trying to figure this out is figure out how many energy levels each thing has. So look at the periodic table and see where silver is. Well, silver's in the 5th row. So silver has 5 energy levels. So let's keep track of that by writing how many underneath. Oops, I got to get my pen. So silver has 5 energy levels. Now calcium is an ion. If we look in the periodic table and find calcium, it's got 4 energy levels. But if it has a +2 charge, that means it has lost 2 electrons. So it would go back in terms of configuration 2 spots because it lost 2 and be like argon. Well, argon only has 3 energy levels, so calcium ion will only have 3 energy levels. Beryllium ion, beryllium's here, but it's losing 2 because it's got a +2 charge, so it's going to get like helium. So it moves back 2 places, and that means it will only have 1 energy level. Fluorine, the atom, is not going anywhere because it hasn't lost any electrons. So fluorine's in the 2nd row, so it has 2 energy levels. Helium is in the first row, so it has 1 energy level. Sodium is number 11. It's in the third row, so it has 3 energy levels. Phosphorus, the atom, is in the third row, so it has 3 energy levels. Sulfur is right next to phosphorus, so it also has 3 energy levels. F-1 is called fluoride. So if we go to the periodic table, F is in the second period. If it gains 1, it'll be like neon, so it'll still only have, 2 energy levels. Phosphorus is in row 3. If it gains 3 electrons, it'll be like argon, and it'll still only have 3 energy levels. So we know the smallest one is the one with the fewest energy levels, but we have a tie. And so when we have a tie, we have to look at the protons next. So which one how many protons do beryllium and helium have? We look in the periodic table. Beryllium has 4, helium has 2. So beryllium has 4 protons. I'm going to put 4 P's up top. And helium only has 2 protons. So the one that is smaller is the one with more protons. So if they have the same number of energy levels, then the one with more protons is smaller. So beryllium is going to be the smallest one up there. And the next one is going to be helium. So the next smallest is going to be one of the ones that has 2 energy levels. And we have a tie. However, they're both fluorine, so they both have 9 protons because fluorine's number 9. That doesn't help us figure out which one's smaller. But if you remember, because the anions, which are negative ions, always gain electrons, they have extra electron-electron repulsions which push out their cloud and make them larger. The anion is always going to be bigger than the atom it came from. So that means fluorine is smaller than fluoride. Now, after that, we got to worry about the ones that have 3 energy levels. They're the next biggest. So we've got 1, 2, 3, 4, 5 that have 3 energy levels. So the first thing we consider, since the energy levels are the same, is the protons. So calcium has 20 protons because it's number 20 in the periodic table. Sodium has 11 because it's number 11 in the periodic table. Phosphorus has 15. Sulfur has 16, and of course phosphide also has 15. Well, remember, if they have the same energy levels, the one with more protons is going to be the smallest because it has more pull on its electrons. So the next smallest is going to be calcium ion. After that, sulfur has the next most, so it'll be next. After that, we have a tie with 15. So remember, the anion's always bigger than the atom it comes from. So it'll be P and then P with a -3, which is called phosphide. And the last one in the third level, the one that's going to be the biggest in the third energy level, will be sodium because it has the fewest protons of the ones in the third energy level. And all that leaves us with is silver. It's going to be the biggest because it has the most energy levels. And that is what you do. So just to remind you one more time, if you're trying to put atoms and ions in order of increasing size, first thing you do is look up the energy levels. Least amount of energy levels is the smallest. If there's a tie, look at the protons. The more protons, the smaller it is. Then, if there's a tie, even with protons and energy levels, then you got to look at the electron-electron repulsions. So if you have a negative ion, it's going to be bigger than the atom it came from. And then just go ahead and put them all in order. We will practice this some in class. Hopefully you understand. I'm sorry, I realized that the periodic table got cut off when I made the video. It didn't show up like that when I was making the videos. But hopefully you have your periodic table out in front of you and you can follow along looking at your own periodic table. I will have some practice problems and paragraphs for you to write using the information in this video. Do your best. And if you have questions, let me know.